2.8 notes. And so we are looking at example 2 here. So for example 2, we are given this graph. Function k tells us it's defined over this interval from -4 to 11, which we can see from the graph anyways. But we want to say that k inverse represents the inverse of k. So first question, what's the minimum value of k of x? Should be very straightforward, right? It's right there. So minimum value would just be -3. So it is the y value here. Now, when it starts asking about inverse of k, which the next part of this question does, and then part B also does, it might be helpful. You don't necessarily have to do this, but it might be helpful to actually draw out our inverse. So I'm going to write out these coordinate points. So 11, 6. This one is 6, 4. This point is 4, -1. And this point is -4, -3. So then the inverse is you switch them around. So 11, 6 is going to become 6, 11, which goes way off this graph. So it's way up here. So again, I'm going to call this 6, 11. Then this one that's at 6, 4 is going to be at 4, 6. So right here, and that would be connected in a straight line. All right, then this 4, -1 is now going to be -1, 4. And again, connect it. And then the last one will become -3, -4. Oops, right here. And of course, it's kind of in the way, but yeah, -3, -4. Okay, so now when it says what is the minimum value of k inverse of x, technically, if you watch my last video, you actually know because this is the domain, the range, since it's the domain of the original, that's also the range of the inverse. So we actually knew the minimum value was -4. Okay, but B is now where it's really nice that I drew both, because now it's saying k inverse of 6. Well, I just now look at my red graph, and k inverse of 6 will equal 11, and then k inverse of 4 will equal 6. So there's those two. Okay, so again, that's why graphing it is very helpful. All right, so then example 3, same idea here. So I would try this on your own before going before watching this. Pause the video and go ahead. All right, so again, you have kind of a few options here. If you wanted to redraw this, you 100% good. But I will say for the answer for letter A, because they tell us the domain, its range, the inverse's range is this, which means the maximum value is just that number right there, right? So that 8. So kind of doing it another way, if you wanted to, is for like part B, where it says if inverse of 3, well, that's just saying, oh, well, my original value or my original graph, it's the y value of 3. So this is the point I would look at, right? Because if I switch the order, now 3 is the x, which is what I want. So this one is 2. And then at 1, it would be this point right here, which would give me 3. And again, that's because the original point is 3, 1. The inverse, you switch the x and y. Or you could graph it. Like I said, either way, you'd still get the same answer. And then our domain of our inverse, remember, is the range of our original function, which our range is from -3 to 7 inclusive. So you can have it this way, or you could write it in the inequality, same idea. But yeah, you just use your original function to help you. All right, so now example 4, we're given a graph and h, and then they tell us that g also exists, g inverse also exists based on the graph. And also h inverse doesn't say it, but it does say that they're increasing, so we can assume that the inverse is a function. So first one, very straightforward, h of 6, right? You start from here. Oh, that's 10. So then I'm going to say g of 10, and g of 10 is -1, and there's our answer. That's from previous sections, so it should be fairly straightforward. Now we're getting some inverses involved. So h of 0 means I want, which is 3. Now I want the inverse of g of 3, which again, since I have the original, I can look at the y value and find its corresponding x. Because again, if I switch those two around, that's going to tell it to me. Or I could graph it, right? So go ahead, take a second, do C. C is basically the same idea, and D, and then come back. All right, so G of 8. I'm starting with G. G of 8 tells me it's 0 because that's just the normal one. So I got H inverse of 0. H inverse, well, the inverse would mean I switch all the x's and y's. So again, if you needed to, you could rewrite the table, but you can also just think, okay, well, for the inverse, my y value is becoming my x. So this is what I'm looking at for H inverse of 0, and that gives me -1. And then here we got both inverses. So let's start with G inverse of -1, which means I'm looking at the y. So that gives me a 10. And then I go ahead and do the inverse, which again, because I have the original one, I'm thinking, okay, x is now 10 and my y was my original x. So it is 6. Okay, and again, if you wanted to rewrite draw the inverse function in for the graph, you can. If you wanted to create a new table where you switch all the x and y's, you can, or just be careful and think through it as well. That also works. All right, well, thanks for watching. Have a good day.